Alright, today's lesson is 10-3 box and whisker plots. We want to be able to construct and interpret box and whisker plots. Those are our objectives for the day. A box and whisker plot can be used to show how the values in a data set are distributed. The minimum is the least value that is not an outlier, and the maximum is the greatest value that is not an outlier. You need 5 values to make a box and whisker plot. You need the minimum number, what's called the first quartile or Q1, the median, which is also known as Q2, the third quartile, which is Q3, and the maximum. Now, I don't want you to write down the words here, but I do want you to draw a little diagram of this down here on your paper. Okay, this is our box and whisker. Our minimums here. This is our first quartile or our Q1. This is our median or Q2. Our third quartile or Q3, and then our maximum number over here, and it makes our box and whisker plot. So again, you do not have to write down the words, but do draw yourself a sketch of the box and whisker plot. Number 1 says a 12-sided die was rolled 20 times. The number rolled each time is given. It says use the data to make a box and whisker plot. Okay, I'm not going to have you write down these because the first thing we're going to have to do to make a box and whisker plot is to put these in order from least to greatest. So as we write these down from least and greatest, that's what I want you to write them down. So our first one, if we're looking, it says list numbers in order from least to greatest with no commas. So we have a 1, another 1, a 2, another 2, a 3, a 4, another 4, and 1, 2, 3 5s, a 6, 2 6s, a 7, an 8, 2 9s, a 10, an 11, and a 12. So again, go ahead. Sorry, 2 12s. Not just one, but 2 of them. So make sure you have all of these numbers listed for number 1. Now we're going to go through. We said to make a box and whisker plot, we needed the minimum, the Q1, Q2, Q3, and the maximum. So we're going to look at these numbers and find that. First thing we're going to do is we're going to find the median, and the median means the middle. So I'm going to find the middle of all these numbers, and it's right here between this 5 and this 6.
And you find the middle by counting how many numbers we have total. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we're going to go, we got 20, so we're going to go 10 in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's going to be our middle. That's where we're going to draw our line for our median. So you need to draw that line between the last 5 and the first 6 on your own paper.
Okay, then we're actually going to find the middle again. We're going to look at the lower half of our data right here on this side, and we're going to find the middle of that again. So our middle here is right between the 3 and the 4, and if you'll notice, we've got 1, 2, 3, 4, 5 numbers on the left of that line, and 1, 2, 3, 4, 5 numbers on the right-hand side of that line. Then we're going to find the middle of the upper half of our data. So our data on this side, we're going to look for the middle of that again, and that's going to be right between these 2 9s. And again, notice I've got 1, 2, 3, 4, 5 numbers on the left-hand side, and 1, 2, 3, 4, 5 numbers on the right-hand side. So we find the middle or the median, and then we find the middle or the median of the second or the lower half, and then we find the middle or the median of the upper half. These are quartiles. The data is now divided into 4 equal parts. These are quartiles. Each quartile contains 1/4 of the data. So I have a 1/4 of the data here, a 1/4 of the data here, a 1/4 here, and a 1/4 here. This one right here, where we find the lower median, is going to be our Q1, and that's going to be 3.5. Since it's not actually at a number, we have to take the 3 and the 4, add them, and divide by 2, and that gives us 3.5 for Q1. 5 and 6, again, we're going to add them and divide by 2, and that gives us 5.5. Here we don't have to because there's 9s on both sides, but if we wanted to, we could add the 9s and divide by 2, and we would get 9 again. So here's our Q1 is this line, our Q2 is our middle, and our Q3 is the middle of our upper half. We also need to go ahead and give our minimum and our maximum. Our minimum is our smallest number, which is 1. Our maximum is our biggest number here, which is 12. So these three values, along with the minimum and maximum, will be used to construct our box plot. So go ahead and draw you the number line here. Your numbers should go from 1 to 12. Take a minute if you need to and pause the video to get your number line. So we're going to plot our minimum, our Q1, our Q2, our Q3, and our maximum. So our minimum is right here at 1, so I'm going to put a dot. I'm going to put a dot right here right between 3 and 4 for my 3.5. I'm going to put another dot right here between 5 and 6 for my 5.5. Another dot over here for my 9. And another one up here for my maximum of 12. Once I have all my points plotted on my number line, I'm going to draw my box and whisker plot. My box is going to go from Q1 to Q3 with a line for Q2. And then my whiskers are going to go out from each side. On this side from Q1 to the minimum value, and on this side from Q3 to the maximum value. So there's my box and whisker plot.
Make sure you have all of that down before you move on. You can pause the video now if you need to. But it says each section of the box and whisker plot is not the same length, but does represent the same number of data. If we look here, these are my numbers 1, 1, 2, 2, 3, 4, 4, 5, 5, 5 on this one, 6, 6, 7, 8, 9 here, and then 9, 10, 11, and 12, 12 go here. So again, there's 1/4 of the data, even though the lines may not be the same length. Quartiles divide a set of data into 4 equal parts. Each quartile contains 1/4 of the values in the set, or in the inner quartile range is the difference between the upper and lower quartiles. The IQR represents the middle half of the data. So again, our range, and you don't have to write any of this down yet. The range is our maximum minus our minimum. So for here it would be 9 minus 1, which would be 8. Our IQR is our inner quartile range. So that's going to be our Q3, which is 7, minus our Q1, which is 3. So that would be 7 minus 3, which is 4. So our range is 8, and our inner quartile range here would be 4. Alright, so we're going to find those for our box and whisker that we just made. We already made this box and whisker, so I want you to write underneath there range and inner quartile range. And we're going to find those. Our range here is our maximum minus our minimum, so that's going to be our 12 minus our 1. And I want you to write here max minus min equals 12 minus 1, which is 11. Our inner quartile range is our Q3 minus our Q1. So I want you to write Q3 minus Q1, and that's going to be 9 minus 3.5, which is 5.5. You need to be able to find range and inner quartile range. Take a minute, make sure you have the range and the inner quartile range written on your own paper before you move on. Alright, here's number 2. Use the data to make a box and whisker plot. Okay, and here's your values. Again, we're going to put these in order from least to greatest. Alright, it says the number of runs scored by a softball team at 14 games is given. Use the data to make a box and whisker plot. The first thing we're going to have to do is list all of these points from least to greatest. So we're going to start out, our least point is going to be 3. So we're going to list 3. Then we have 4. Then 5. Then we have 2 6s. 1 9. 2 10s. 2 11s. 2 12s. 1 15. And 1 20. So make sure you have all of these numbers listed from least to greatest. You have 3, 4, 5, 6, 6, 9, 10, 10, 11, 11, 12, 12, 15, and 20. Let's count our numbers and see. Okay, we don't have to count them. We can see right here there are 14 games. So I should be able to go 7 into this data set and draw my line to find the median. So 1, 2, 3, 4, 5, 6, 7. There should be my line for my median, and there it is between the 10 and the 10. So now I'm going to have to divide this set in half to find my Q1. You may realize very quickly that 7 is not going to split evenly down the middle, so we've shown that by drawing a line through the 6 here. That is going to be my median number. And then here, I'm going to go 1, 2, 3, 4, and I'm going to draw a line through the 12 to find my upper median, or my Q3. So that's going to be 12 quartiles. The data is now divided into 4 equal parts. 1, 2, 3, 4, and these are quartiles. Each quartile contains 1/4 of the data, just like it did last time. Again, my Q1 is going to be 6. My Q2 is going to be 10, and even though it's between the 10s, they are the same number, so I don't have to find the average. I could, if I wanted to, add the 10s together and divide by 2. I would get 10. And then my Q3 is going to be 12. So now we're going to look at our minimum and our maximum. My minimum, or my lowest number, is 3. My maximum, or my highest number, is going to be 20. And it says these 3 values, along with the minimum and maximum, will be used to construct a box and whisker plot. So now I need you to draw your number line from 0 to 20. You can do it like ours is, where you have gone up. You've shown 5 increments, but you've only written every 5, 0, 5, 10, 15, and 20. You can pause the video right now if you need to do that. When you are done, you may continue on. We're going to plot our points above the number line. We're going to put our maximum at 3.
Minimum at 3.
I'm sorry, our minimum at 3. Thank you. Our Q1 at 6. Our median at 10. Our Q3, or third quartile, at 12. And then our maximum, for real this time, at 20. Now, once you have all of your plots pointed above your number line, you can go ahead and draw your box and whisker plot. It says each section of the box and whisker plot is not the same length, but does represent the same number of data, just like it did last time, the last example we looked at. There you have your 3, 4, and 5, your 6, 9, and 10, your 10, 11, and 11, and then your 12, 15, and 20. Our next step is to find the range, or the interquartile range. So you have here range and interquartile range. You need to write those down. Our range, again, is our maximum minus our minimum, and I need you to write max minus min equals 20 minus 3 equals 17. So our range of data is 17 from 20 to 3, gives us 17. And then our interquartile range is Q3 minus Q1. Write that down. And then our Q3 again was 12, and our Q1 was 6. So 12 minus 6 gives us 6. So our interquartile range is 6.
All right, on part C, it says answer the question below. It says what percent of runs scored is from 6 to 12? So from 6 to 12 is from here to here. Okay, and we've talked about how this is a fourth, this is a fourth, this is a fourth, this is a fourth of our data. So if I have 2/4 of our data, I actually have half of our data from here to here. So that is 50%. And it says what fraction of the runs scored is from 3 to 6? So that's from here to here. And that's going to be 1/4, because again, we talked about how even though these lines are not the same length, they all contain the same number of data. So it's 1/4, 1/4, 1/4, and 1/4. So from here to here is 1/4 of the data. Make sure you have both of those questions and answers written before you move on. If you need to pause the video, that's fine. All right, number 3 says the box and whisker plot show the ticket sales in millions of dollars of the top 25 movies in 2000 and 2007. It said for U.S. only. You do not have to draw the picture or write the question down for this one. I do need you to write A and write which year has a lower median ticket sale. So again, we're looking for the median or the middle. That would be our Q2. So we're going to look and say, okay, which one has the lowest? So if I'm looking, year 2000 is right here at 125, and then my 2007 is right here. So my lowest one is in 2000. So we're going to say year 2000 for this one. B says approximately how much lower is the median ticket sale for the year 2000. And we're going to kind of have to approximate here for this one because it doesn't tell us, but it's somewhere between 150 and 175. So we're going to say 170 million minus 125 million for the year 2000. So I'm going to take and subtract this one this one minus this one, and that's going to give us 45 million. Please make sure you have the word million there. So it says approximately how much lower is the median ticket sale for the year 2000? It's 45 million. Make sure you have part A and B written down before you move on. Alright, on number 3C says, which year has the highest ticket sales, and estimate the amount. So we're going to look at the maximum, which would be our highest ticket sale. And right here, this one comes down right here, and this one's way up here. So obviously year 2000 has a much higher maximum.
2007.
Or sorry, year 2007 has a much higher maximum than year 2000. So we're going to say year 2007 has a greater maximum or highest ticket sale. And we're going to approximate this to be about 340 million. Again, if you were doing the one approximating, you could be off by a little bit, but again, it's just an approximation here. Make sure you have C and the question and the question and the answer written. Part D says, which data set has the greater interquartile range? So all we're looking here is to say which one has the bigger box. So if it has a greater interquartile range, the box is going to be bigger because the interquartile range is Q3 minus Q1. So here, the year 2000 has 175 minus 110.
Okay.
Alright, sorry, here 2007 we had 175 minus 110.
2000.
Year 2000 has 175 minus 110 for its IQR, which is 65. And for year 2007, we have 240 minus 130, which is 110. So 2007 has the greatest interquartile range.
And honestly, you can look at your box and whisker plot that you're given, and you can go ahead and tell right here, because 2007 is a wider box. That shows us by the wider box here, based on the number line, that it's actually going to have a wider or greater interquartile range.
And part E says, what does this tell you about the data set? The middle half of the data varies more than the year 2000 ticket sales. So go ahead and make sure you have D and E written before you move on. Part F says, what is the range of the data set for the year 2000? So the range is the highest minus the lowest. Alright, so part F says, what is the range of the data set for the year 2000? So I have to take the maximum and subtract the minimum here. And again, I'm going to have to approximate because it doesn't give me the exact. So I'm going to say that in 2000, it is 260 minus 90, which is 170 million. And part G says, what is the range of the data set for the year 2007? So again, I'm going to have to do the same thing. I'm going to have to take my maximum and approximate it, and my minimum and approximate it, and subtract those. So I'm going to say 335 minus 120 gives me 215 million. Again, your answer, if you were doing this on your own, would vary some. Make sure you have F and G written before you move on. Alright, number 4 says the box and whisker plot shows the number of mugs sold per student in 2 different grades.
Alright, A says, about how much greater was the median number of mugs sold by the 8th grader than the median number of mugs sold by the 7th grade? So you're going to look at your 8th grade median, which is right here, and it's going to come down somewhere between the 35 and the 40. And then you're going to look at your 7th grade median, which is right here, and it's coming down between the 30 and the 35. So we're going to approximate that to say that our median for the 8th grade is 38, and our median for the 7th grade is 32. So 38 minus 32 is going to give us 6. So we're going to say that the median for the 8th grade is 6 greater than the median for the 7th grade. Sorry. Make sure that you have that down.
That's all you have to do for this one. Don't write the question, just write the answer.
Sorry.
For A. Just write the 38 minus 32 equals 6.
And then for part B, again, you don't have to write the question, just the math part. It says, estimate the difference in the most number of mugs sold per student in the 8th grade and the most number of mugs sold in the 7th grade. So our most means that we're looking at our maximum, In our 8th grade, it's falling between the 70 and the 75, and in our 7th grade, it's falling between the 55 and the 60. So we're going to estimate that to say that that's 74 for our maximum in the 8th grade and 57 for our maximum in the 7th grade. So 74 minus 57 equals 17.
And I know I'm subtracting because it says estimate the difference, and difference means for you to subtract those two numbers.
So 17 is our estimated difference between the most number of mugs sold per student in the 8th grade and the most number of mugs sold per student in the 7th grade.
Again, all you have to have there is the answer. The 74 minus 57 equals 17.
Part C says, which data set has a greater interquartile range? Now, with the last one, we were able to kind of look at it and see that the box was definitely more spread out in one year than it was the other. Here, it's not quite as simple, so you need to make sure that you do the specific math here. You have 8th grade, which comes down right at the 55, and the 30 for the Q2 and Q1. Q3 and Q1, and I did it backwards because it did 7th grade first. And then for the 7th grade, you have what we're estimating or approximating to be 44 for the Q3, and then the 20 for the Q1. So Q3 minus Q1 gives us 24 for the 7th grade. Sorry, our font is off there. And then our Q3 for the 8th grade is 55 minus 30, which gives us 25. So again, like I said, you couldn't obviously look at these and see which box was more spread out, and there's a reason for that, because if you'll notice, your interquartile range is literally 1 point off between your 7th and your 8th grade. So 7th is 24 and 8th is 25. So the 8th grade does have a greater interquartile range. So again, our 8th grade is our winner here with the greater interquartile range.
All right, number 5 says the box and whisker graph below represents the prices of 20 different brands of backpacks. So we have the price of backpacks in dollars. It says which statement is supported by the graph. So you're looking for the statement that's true. Statement A says the least price is $30. So if I look here at my least price, it's actually $15. So it's not A. The greatest price is $45, so my greatest price would be my maximum. My maximum here is $65, not $45, so that one's not correct. It says the median price is $35, so if I look at the median, I'm looking for the Q2, and it's right here, and it actually is at $35. So my correct answer here is C. And it says the prices are between $35 and $45. The prices aren't between those, they're actually between $15 and $65. So C is your correct answer for number 5. All I need you to write down for this one is number 5, C, the median price is $35. It says this is the box and whisker question from the EOC practice test. Alright, we're not going to do the before you go. Alright, so I changed my mind. I do want you to go ahead and do and try the before you go. Okay, so just on the bottom part of your notes, go ahead and try this. It says find the following values for the box and whisker plot. You're going to find the minimum, the Q1, Q2, Q3, the maximum, the range, and the interquartile range. Take a minute and pause the video and try this, and then we're going to look at the answers. Alright, go ahead and check your answers and see if you got those correct. If not, please change and fix them. Your homework's written at the top in the yellow, so you can go ahead and write that down. Okay. You can go ahead and get started on your assignment. That is the end of your video. Thank you for watching.
Please note on the homework that 10 and 23 are underlined because you have to make a box and whisker plot and find the range and the interquartile range for both of those problems.